Good morning to all and all present here. So in this session we are going to see about ratio of transformer. So in that ratio we are having three ratio. One is voltage ratio, second one is current ratio, and third one is voltage amp ratio. So first one is voltage ratio. The voltage E1 is equal to 4.44 F 5M N1. In current ratio it is given as V2 by V1 is equal to I1 by I2, that is equal to K. In volt ampere ratio, it is V1 by V2 equal to I2 by I1, just opposite to current ratio, that is equal to K. So kilowatt rating of a transformer is equal to V1 I1 by 1000 is equal to V2 I2 by 1000. So here we can see the equivalent circuit of a transformer. So in that we are having a resistance reactance R0 and an inductance X0, where the current flowing in the X0 is Im and the current in R0 is I0 and IC. So R0 IC is equal to V1 and V0 Im equal to V1. Similarly, Im equal to I0 sin phi 0 and IC is equal to I0 cos phi 0. So refer to the primary and secondary slides respectively. You can see the equivalent circuit of a transformer. So in that we are having a resistance R1 X1 in the front in primary coil, and in the secondary coil we are having X2 and R2. So already I have told that for a transformer we need to have a primary winding and a secondary winding. So depending upon the secondary winding we can divide the transformer into two types, that is step up and step down. If the winding of the secondary winding of the secondary coil winding is lesser than the primary coil, we call that as a step down. If secondary coil winding is more than the primary coil, we call that as a step up. So step down transformer are used in electronics and communication circuits, and step up is used in our electrical circuits. Next one, we are going to test the performance of the transformer by using open circuit test and short circuit test. And this performance of a transformer can be calculated on the basis of equivalent circuit. There are four parameters of equivalent circuits are referred as. R01 is referred to primary and R02 as secondary. The equivalent leakage X01 is referred to as primary or secondary X02. Magnetizing susceptance B0 and core loss conductance G0. The above constants can be easily determined by two tests. One is open circuit test and another one is short circuit test. So first we will see open circuit test. So here the diagram represents the open circuit test, in that we are having an ammeter and wattmeter for measuring the power, and ammeter for current and voltmeter for voltage. We are connecting that in a primary of a transformer, and we are going to have the voltage E2 is equal to V2 at the secondary winding of a transformer. So in open circuit test, secondary winding is open circuited and the primary winding is connected to a full load line voltage. Usually conducted on high voltage side to find number 1 no load loss or core loss, number 2 no load current I0, which is helpful in finding G0 or B0 and B0 or X0. Next one is short circuit test. Secondary terminals are short circuited. Second one is primary terminals are connected to a fairly low voltage source. In open circuit test, the load is open circuited. We are not connecting any load at the secondary, whereas in short circuit test we are connecting a load in the secondary of a transformer. So same thing, we are going to calculate the power by using wattmeter, and ammeter is used for calculating current, and voltage is used to calculate the voltmeter. Next one is, what are the losses occurred in a transformer? There are two losses. One is core loss and another one is copper loss. The core loss is otherwise called as iron loss, which is mainly due to hysteresis, and I square R loss or copper loss is mainly due to resistive heating. For first we will see core loss. Other name is iron loss. Copper losses are the resistive heating losses in primary and secondary winding of the transformer. Hysteresis loss is equal to KHBM 1.67 F into B. So next one is copper loss. Copper loss is equal to, that is total copper loss is equal to I1 square R1 plus I2 R2. That is equal to I1 square into R1 plus R2 dash. That is equal to R2 plus R1 dash. So similarly, we can write this as I1 R1 is equal to I2 R2. So total copper power is equal to, is directly proportional to I square, and it is actually proportional to kVA whole square. So total loss is equal to iron loss plus copper loss, that is P1 plus PCU. So iron loss due to voltage and copper loss due to current. Next one, regulation of a transformer. Full load voltage regulation is the quantity that compares the output load at no load with the output at full load. Voltage regulation. No load voltage minus full load voltage divided by no load voltage. So in order to get a regulated output, we need to calculate the voltage of by using this formula while we are doing the problem. E2 represents the secondary terminal voltage on the no load and V2 represents the secondary terminal voltage on the given load. So no load means there won't be any load at the secondary. If we are having the load, we call that as a load connection in the secondary. So percentage of voltage regulation is equal to E2 minus V2 by V2 into 100. So thus we can able to calculate the efficiency output by input by using the efficiency formula eta equal to P out by P in into 100 percentages. The transformer efficiency is defined as applies to motors, generators and transformer. We are going to calculate this formula eta P out by P out plus P loss into 100 percentage. You have to calculate the output power along with their losses. From that we have to calculate the efficiency. Therefore, for a transformer, efficiency may be calculated using the following formulas. Eta is equal to Vs Is cos theta divided by copper loss PCU plus core loss P core plus source voltage Vs and source current Is and the power factor cos theta into 100 percentages. The condition for maximum efficiency P1 minus I1 square R2 equal to 0 and P1 equal to, already we told that I2 R2, that is equal to copper loss. So copper loss is equal to core loss. We can obtain the condition for maximum efficiency. So next one, we need to have auto transformer. So auto transformer is nothing but, in the primary winding we are having only one winding. So a common winding is used for both primary and secondary. We are going to split one winding into two. One act as primary and the other act as secondary. So here we are having, in the diagram it clearly shows that we are having only one winding. The upper part we are going to connect to the secondary and the lower part is connected to the primary, right? An auto transformer, sometimes called as auto step down transformer, is an electrical transformer with only one winding. A portion of same winding act as both the primary and secondary sides of a transformer. So next we will see the operation of auto transformer. Here we have a winding, that is a common winding is separated between for primary and secondary winding. An auto transformer has a single winding with two end terminals. The primary voltage is applied across the two of the terminals. The secondary voltage is taken from two terminals. So primary is applied in the front side and secondary is applied in the second side, back side. So both are applying in the same winding, almost always having one terminal in common with the primary voltages. So what are the advantages of this auto transformer while we are using only one winding means? First point, its efficiency is more when compared with the basic transformer. Second one, its size is relatively very smaller. Third one is voltage regulation of auto transformer is much better. And fourth one is lower cost. Fifth one is low requirements for excitation current and less copper is used in the design and construction. Right. Next one is where we are going to apply this or use this auto transformer. Number one, it can be used in both synchronous motors and industrial motors. Number two is used in electrical apparatus testing labs, since the voltage can be smoothly and continuously varied. Point number three is they find application as boosters in AC feeders to increase the voltage levels. In order to increase the voltage level, we can use this auto transformer for the AC feeders. Thank you.